Hello everyone, I welcome you all to Physics Wala, and in this session we are going to start the new portion of chemistry, which is basically the concept related to organic chemistry. And the chapter which we are discussing is basically some basic concepts of organic chemistry, or I can say the topic which we are going to start is basically the nomenclature of organic compound. So this session is going to be very interesting. But before that, let me introduce myself. My name is Arpit Bharadwaj and I am a chemistry faculty at Physics Wala. Now, basically, in this session, what we are going to discuss, first of all, we are going to introduce the part which is a very interesting portion related to the organic chemistry. Then we are going to discuss about the next portion, how to represent different type of organic compounds. Whenever we are dealing with the organic compounds, you should know how to represent them, what is the actual expanded formula, what is the condensed formula, as well as the bond line notation. In the same way, we are going to discuss about the next part, which is the concept of functional groups, because they are very important in case of organic chemistry. And last part, we are going to discuss about the nomenclature of all these type of organic compounds. Okay. Now, before starting, if I talk about the concept related to organic chemistry, so the introduction part is basically the concept of organic chemistry. So what is the meaning of this branch of chemistry? Basically, this branch of chemistry actually deals with the compounds. We are going to deal with the compounds of carbon and hydrogen, which are actually known as hydrocarbons. But we have discussed certain compounds of carbon and hydrogen in inorganic chemistry also. But most of the compounds are basically derived from the earth crust. So basic idea of organic chemistry or organic compound is those compounds which were present in the living beings or living organisms. This was the old definition, old concept. But now we know that organic chemistry is nothing but the study of all the compounds. It is basically the study of all the compounds of carbon and hydrogen. So what is the nature of these compounds? That we already know from the concept of chemical bonding, that we are talking about the covalent compounds. Okay, so basically we are talking about the covalently bonded compounds. What is the meaning of covalently bonded compounds? All those compounds in which the bond which is present is basically covalent bond, or the bond which is formed by the equal sharing of electrons. That part corresponds to the covalently bonded compounds. So in that case, you can say we are talking about the equal sharing of electrons. So what is so special about these particular compounds? Only we are going to include carbon and hydrogen? So no. In this case, if I talk about the organic chemistry, we are talking about the organic compounds. We are talking about the organic compounds. And basically in these organic compounds, we are going to discuss about the hydrocarbons and their derivatives. This is the most important portion. Hydrocarbons as well as their derivatives. So what is the meaning of these derivatives? In this case, you can have carbon, you can have hydrogen and other functional groups, or I can say other side heteroatoms, which can be fluorine, chlorine, bromine, oxygen, sulfur, nitrogen, etc. Okay, so along with these particular type of atoms, we are talking about different type of functional groups which corresponds to their derivative part. Okay, so in this case you already have certain idea from your 10th class. If you remember the organic compounds from your 10th class, you have a basic idea about the actual representation, actual analysis of these organic compounds. Now the main thing in that case, why we are only talking about the carbon, why this carbon is so special, why there are enormous type of compounds related to carbon in case of organic chemistry. Because you know, if I talk about the organic compounds, like there are different type of organic compounds. It can be alkane, alkene, alkyne. That is a basic analysis. But why we are selecting only carbon in this particular case? There are certain properties of carbon which are actually relevant to us. That's why we have chosen carbon to form different type of organic compounds, and the main composition is always with carbon as well as hydrogen. So when these two things are actually covalently bonded, they can form different type of compounds. But there are certain properties of carbon which are actually very important. First part, in this particular case, you can say this is because of the catenation. Just because of the catenation. Catenation is basically the property which is known as self-linking property. This particular part is self-linking property, because carbon has a tendency to actually form different type of bonds with itself. So it's not like self-linking property. Carbon can form different bonds with other carbon atom. It has also a property, it can form compounds with other atoms also. Means carbon can bond with oxygen, very interesting part. Okay, carbon can link with nitrogen, carbon can link with fluorine, carbon can link with chlorine, carbon can link with bromine, carbon can link with iodine. Okay, so just because of this property which is known as the self-linking property, carbon can easily form different type of bonds. And in that particular case, if I expand this property, so one of the property is catenation, which is known as a self-linking property. Other than that, it can also make bonds with oxygen, nitrogen, fluorine, chlorine, bromine, iodine, sulfur, phosphorus, whatever species we have, it can easily form bonds with those species as well. What about the second portion, like why this entire part of organic chemistry is so special? So in that case, second part is basically it's a tetravalency. It's a tetravalency. It means carbon can form 4 bonds with other carbon atoms or other heteroatoms. It can easily form 4 bonds with simple carbon atoms as well as different heteroatoms. What is the meaning of heteroatoms? Atoms other than carbon. So in that case, it may be oxygen, it may be nitrogen, it may be sulfur, it may be chlorine, bromine, fluorine, whatever it is, it can easily form 4 bonds with other atoms also. That is the basic property of catenation as well as tetravalency. In the same way, if I talk about the next part, which is very interesting, that is tendency to form multiple bonds. It means carbon has the tendency to form multiple bonds also. It can form carbon single bond carbon, it can form carbon double bond carbon, it can form carbon triple bond carbon. Other than that, it can also form carbon double bond oxygen, carbon bond with nitrogen, or you can say carbon bonded with nitrogen triple bondedly. Okay, so just because of these properties, first one is catenation, second one is a tetravalency, and last one, which is your tendency to form multiple bonds. We have a specific classification for compounds of carbon as well as hydrogen, which are actually known as hydrocarbons. Okay, other than that, if I talk about the next part, why carbon is so special, in that case you should know that in case of a carbon, bond energy of carbon carbon bond is actually high. It means the bond which is going to form between carbon carbon is going to be very strong, because both are non-metals, so definitely bonding is going to be covalent. But in this case, the bonding is very strong, very dominating. That's why we have a specific classification related to these organic compounds, and we have million of compounds related to these hydrocarbons. I hope the basic idea related to the formation of these compounds is clear to everyone. That is the very basic portion related to the entire part. Okay, now along with that, if I talk about the organic compounds, So organic compounds are basically compounds which are formed by carbon, hydrogen and other heteroatoms. They are covalently bonded compounds. But in that particular case, if I talk about the entire introduction part of organic compounds, we should know certain things about carbon. So in case of carbon, if I talk about these type of compounds, first of all, you need to understand some concepts from chemical bonding itself. So I am using certain concepts from chemical bonding. Okay. So what are the concepts which we are going to discuss in this particular case? First part is basically the concept of hybridization. So if you know the hybridization, you know the orbitals which are involved in the hybridization, you know the actual geometry, you know the actual structure. So hybridization gives us the idea about the geometry as well as the shape, and also talks about the concept of bond angle and bond length. Okay. In the same way, next part is your VBT. VBT is basically your valence bond theory. VBT is basically your valence bond theory. And next part is basically your VSEPR theory, which is valence shell electron pair repulsion theory. This part you already know from your chemical bonding portion. If you don't know, you can refer to the chemical bonding portion. And you can see the basic concepts of hybridization, VBT as well as VSEPR to actually know more about the entire analysis. Like if I talk about the carbon in this particular case, there are certain things which you should know. I'm going to revise entire part very quickly. So let's start with the compound which is, let's say, CH4. I'm starting with the compound which is CH4. CH4 is also known as methane. I'm not talking about the nomenclature, but this part we already know. CH4 is basically methane. If I talk about the concept of this methane, how you are going to derive the hybridization, because in case of methane, basically we have hydrogen, hydrogen, hydrogen as well as hydrogen. So basically 4 hydrogens are there. In this particular case, I'm going to use a concept of VBT, because VBT talks about the formation of a sigma as well as pi bonds. It talks about the formation of sigma as well as pi bonds. So in this particular case, if I want to ask you what will be the hybridization, so you can simply say hybridization we can actually calculate by simply calculating the steric number. So in case of steric number, what you can do? You can say, sir, this will be total sigma bonds formed by the central atom plus lone pair of electrons. Both are on the central atom. So if you know this entire part, because in case of hybridization, we never include pi bonds. So definitely we are only talking about the sigma bonds as well as total number of lone pairs which are present on the central atom. If this part we know, we can talk about the steric number. So if the steric number is, let's say, 2, it means its hybridization will be sp. If this steric number is 3, its hybridization will be sp2. If this steric number is actually 4, hybridization will be sp3. And mainly whenever we talk about the concepts which we are using for from the chemical bonding part in case of organic compounds, generally always remember that in these cases we are going to deal with sp, sp2 and sp3 carbon atoms, because carbon can only form up to 4 bonds. That's why the hybridization always restrict to these 3 parts. In this particular case, we can say geometry will be linear. In this case, it's going to be trigonal planar, and in this case, it's going to be tetrahedral. Okay, so this is the basic part which you all know from the chemical bonding portion. I hope this part is clear. Now talking about this particular compound which is a methane. In this particular case, I can say that steric number is very easy to calculate. We have total 4 bonds, 4 sigma bonds are there. So 4 sigma bonds, 0 lone pair, it means total number will be 4. If that is the situation, we can say its hybridization will be sp3. If its hybridization is sp3, it means its geometry will be tetrahedral. Now from the tetrahedral geometry, there are certain things which you need to understand. In this particular case, the bond angle is 109 degree 28 minute, or you can say 109.5 degree approximately. Okay, so from that part you can say that bond angle will be 109 degree 28 minute. I hope this part is clear. Now, how many bond angles are there? So, you can say one angle is there, one angle, one angle. So, how to understand this entire part? Let's say this is H1, H2, H3 and H4. For simplicity, I am just using the notation 1, 2, 3, 4, but it has no meaning. Like all the hydrogen atoms are actually same, but for simplicity, I am using this entire part. So, one bond angle between one carbon and 2, one carbon and 3, one carbon and 4. So, 3 bond angles are already there. 2 carbon and 3, 1 bond angle, 2 carbon and 4. Okay, and next part is 3 carbon and 4. So, total you can find out how many angles? Total 6 angles are there, which are 109 degree 28 minute. This is the basic idea from the chemical bonding. Okay, just have a look at it. Okay, now in the same way, if I talk about the next portion, let's say we are talking about the C2H6, next part, C2H6. So this looks like C double bond C, then H and H, H and H. Okay, this part we already know. First part was methane, second part in this particular case is basically your ethene. This part is known as ethene. So I am including everything. You should know what is the basic idea about the hybridization. So in this particular case, if I talk about the steric number, we never include pi bonds. So I can say 1, 2, 3. Total 3 sigma bonds are there. So 3 sigma bonds plus 0 lone pair. That will be 3. It means in this case, hybridization will be sp2. If that's the case, we can say that its geometry will be trigonal planar. If the hybridization is sp2 and geometry is trigonal planar, bond angle in this particular case will be 120 degree. 120 degree. Okay. In the same way, if I talk about the next contender, which is a C2H2, also known as ethine. Okay. In this particular case, you can see that we have carbon, triple bond carbon, H and H. So carbon can form single bond, carbon can form double bond, carbon can form triple bond. Okay. So in this particular case, again you can calculate the steric number. You can say total we have 1 and 2. 2 sigma bonds are there. 0 lone pair. It means steric number is 2. So hybridization will be sp in this particular case. If that is the case, geometry will be linear and bond angle will be 180 degree. I hope this part is clear. I hope this part is clear. Now, one thing which I want to mention in this particular case, is first part. Just look at this structure. The hybridization comes out as sp3. Can you calculate the percentage S character? Yes, very easily. Sir, we have only 1s and total 4 orbitals are there. 1s and 3p. So, 1s and total 4 orbitals multiplied by 100, that will be 25% only. That will be 25% only. In second case, if I talk about the percentage S character, as the hybridization is only sp2, so 1 S is present and total orbitals are 3 multiplied by 100, that will be 33.3 percentage. In this particular case, percentage S character will be 1s and total orbitals are only 2 sp. So 1s and 1p. So multiplied by 100, that will be 50%. One thing from this data you can see that when the percentage S character was only 25%, the bond angle was 109 degree 28 minute. When the percentage S character actually increases bond angle becomes 120. And further, if it goes to 50% percentage as character, bond angle actually becomes 180 degree. So one thing which you should note down in this particular case is a very interesting, that percentage as character is a directly proportional to bond angle. I hope this entire part is clear. I hope this entire part is clear. Just have a look at it. These are the basics from your chemical bonding portion. So I know that you guys are already aware of these entire parts, like what is the hybridization, how to calculate the hybridization, what about the calculation of bond angle, as well as the analysis related to their percentage as character. Now one thing which is very important from VBT is basically total sigma and pi bonds. Okay, total sigma and pi bonds. So when only single bond is present, so carbon single bond carbon, this bond is going to be sigma. If it is carbon double bond carbon, so according to VBT, one should be sigma and another should be pi. In case of a carbon triple bond carbon, one is sigma, rest two are pi bonds. This is the basic nature according to VBT. So let's talk about methane only. So in case of a methane, which is CH4, you can say total sigma bonds are basically 4. Total pi bonds are basically 0. Because in case of a methane, every bond is single bond. Every bond is single bond. So there is no concept of pi in this particular case. In the same way, if I talk about the next part, which is, let's say, your ethene, which is C2H4. In this particular case, this will be C double bond C, then H, H, H as well as H. Okay. So this is sigma, 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 sigma and pi. So how many sigma bonds are there? Total sigma bonds are 5 in this particular case, and pi bonds are basically 1. Only one pi bond is present in this particular case. In the same way, if I talk about the next part, which is ethyne, that is C2H2. So in this particular case, you can say we have C triple bond C, then H as well as H. So one sigma and one sigma. Rest two are pi bonds in the multiple bond formation. So you can say total sigma bonds are 1, 2, 3 and pi bonds are basically 2 in this particular case. Okay, that is the calculation related to sigma as well as pi bonds. Just note down this important portion. It's a very interesting thing. You can find certain questions related to the calculation of sigma as well as pi bond in examination as well. Okay. Okay. Now let's talk about certain questions. Let's talk about certain questions. Calculate total sigma and pi bonds in the following compounds. Okay. Let's say first one is benzene. Initially, I am using all those compounds which you already know from your previous classes. Okay. Second one is acetic acid. Third one is your ethanol. Next one is your phenol. Okay. So try to solve these questions and let me know the answer in the comment box. Okay, just pause this entire part and try to solve total number of sigma and pi bonds in these compounds first. Okay. Okay, so if you solve this entire part, okay, so benzene is basically C6H6. Benzene is C6H6. So if I draw the structure, it's a very common structure. Carbon, carbon, then we have carbon, carbon and carbon. Double bond, double bond, double bond. Alternate double bonds are actually present in this particular case. Rest are hydrogen. Because carbon is a tetravalent, so definitely you have to form total 4 bonds. So this is the actual structure of benzene. Now if I talk about the sigma as well as pi bonds, I can see total 3 pi bonds are there. So total 3 pi bonds are there. Now if I calculate 1, 2, 3, 4, 5, 6, 6 sigma bonds are already present between carbon carbon and 6 with carbon hydrogen. So total are 12 in this particular case. I hope this part is clear. Next part is for acetic acid. Acetic acid also known as CH3COOH. Okay, ethanoic acid CH3COOH. If I talk about the structure of CH3COOH, it looks like CHHH C double bond OOH. Okay, this is the structure of acetic acid. In this case, you can again calculate total sigma as well as pi bonds. As I can see, only one multiple bond is there. If one multiple bond is there, you can say total one pi bond is present. So one pi bond is present in this particular case. Now calculate the total number of sigma bonds in this particular case. So 1, 2, 3, 4, 5, 6 and 7. So total 7 sigma bonds are present in case of acetic acid. Next part is ethanol. Ethanol is CH3 CH2 OH. Next part is a CH3 CH2 OH. If you draw the structure, it looks like CH H H C H H O H. This is the actual structure. I cannot see any double bond or any multiple bond. If that is the situation, it means pi bonds are 0 in this particular case. But if I calculate the sigma bonds, I can see 3, 4, 5, 6, 7, 8. Total 8 sigma bonds are present in case of ethanol. And last part is a phenol. Very interesting compound. Very interesting compound. This is basically C6H5OH. The formula is C6H5OH, just like your structure of benzene. So if I draw the structure, it looks like carbon, 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 then carbon, 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 alternate double bonds, and this one will be OH, rest are H. Okay, so in this particular case, if you calculate the total sigma as well as pi bonds, I can see only 3 multiple bonds are there, which are double bond. So 3 pi bonds are already present. If I talk about the sigma bond, 6 carbon carbon sigma bonds are present, 6 with these part and 1 additional is there. So that will be 13. Okay, I hope now the entire portion related to the calculation of a sigma as well as pi bond is clear to everyone. Just have a look at it. Okay, now next part is related to the notation or representation of organic compounds. So whenever we talk about the representation, we have expanded formula structure. Next one is condensed formula structure, or you can say expanded structural formula. Expanded structural formula. This one will be condensed structural formula. And last part, which is very interesting, is bond line structural formula. Okay, the most used notation, or I can say representation in case of organic compound, is basically bond line structural formula. But the thing is, how to draw these type of structures? How can we expand this entire part? So let's say the compound given is let's say we have ethane. Okay, now in case of ethane, its molecular formula is basically C2H6. Its molecular formula is a C2H6. Now I can do one thing, that is I can expand this entire part, CHHH, CHH as well as H. I can expand this entire part. Okay, this one will be ESF, expanded structural formula. Or I can use, in case of condensed formula, you can actually use carbon with hydrogen as it is. There is no need to represent the bond of carbon and hydrogen. So that will be CH3 and CH3. So in this case, no need to show carbon hydrogen bond. You can only show carbon carbon bond. Okay, so that will be the condensed structural formula. That will be the condensed structural formula. Now what about the bond line notation? In case of bond line notation, always remember, only line shows bond between carbon carbon atoms. Okay, only it shows carbon carbon atoms. There is no need to show carbon hydrogen. There is no need to show any other possibility. So if I want to represent this entire part, I can simply draw one line. So one end of this line will be CH3, another end of this line will be CH3 again. I hope this part is clear. Just have a look at it. In the same way, let's say if I talk about propane, its molecular formula is basically C3H8. That will be the formula. Okay, in this particular case, either you can write down CHHH, CHH, CHH as well as H. Okay, that will be expanded structural formula, ESF. If I want to show the condensed formula, I can only use carbon carbon bond. So that will be CH3 on one side, then we have a CH2 and then CH3. That will be condensed structural formula. Now in case of a bond line structural formula, you can use zigzag line to show the tetrahedral structure. Okay, so 1 2 3 three carbon atoms are there, so you can use the representation like this. I am writing it here, 1 and 2 and 3. Okay, so this is the structure which is known as the bond line structural formula. Okay, I hope this entire part is now clear. Just have a look at it. Okay, now let's try to practice certain other questions also to actually get the idea how to draw the bond line notation, which is the most important portion. Okay, so let's say I'm starting with the first part. we have okay, let's say this is the structure. Okay, let's try to decode this entire part. This is the expanded structural formula. Expanded structural formula. So if I want to write, the condensed formula, I can write it as CH3, then we have CH and F, okay, then we have CH, CH3, then we have CH2, and then we have CH3. Okay, so this is the notation which is known as the condensed structural formula. Okay, what about the bond line notation? So in this case, 1, 2, 3, 4, 5. 5 carbons are there. So I can use 1, 2, 3, 4, and 5. 5 carbons are there. Now next part is 1, 1, 2. On second part, you have one fluorine. So you need to represent that fluorine also because it's a heteroatom. There is no need to show the hydrogen bond, but you have to mention the heteroatoms. Okay. Next part is 1, 2, 3. On third case, you can again see one CH3. So one single line which shows the presence of CH3. Okay. Then CH2, CH3, CH2, CH3 as it is. Okay. So this one will be the bond line structural formula. Okay, I hope this part is clear. Now what about this particular compound? In this case you can see we have carbon, 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 carbon as well as carbon. Okay, this is the structure. So that will be CH2. In this case we have CH, CH3, then we have CH, C2H5, C2H5, and then we have a CH2, and then we have CH2. This is the condensed structural formula. This is the condensed structural formula. And last part in this case, the bond line notation. So you just have to make a ring of 5. Okay, first part. And in this case, one CH3 is there. In this case, one C2H5 is actually present. Just have a look. This is the actual analysis about the bond line notation. I hope this entire part is clear. We are going to practice different type of questions in this particular case. Don't worry. Now, the next portion is related to the presence of different type of atoms other than carbon and hydrogen. So basically the meaning of a functional group is very easy. That atom or group of atoms on which properties of organic compound depends is actually known as your functional group. So it can be a single atom, it can be a group of atoms, which is going to change the physical as well as chemical properties of that particular organic compound, are basically known as your functional groups. So in case of a simple part, you can have carbon with hydrogen. There is no concept of functional group in this particular case. It's a simple hydrocarbon. It's a simple hydrocarbon. But if I am changing, if I am on changing hydrogen with other atoms or group of atoms, okay, if you are changing hydrogen, if you're replacing hydrogen with an atom or group of atoms, then definitely you are changing the physical as well as chemical properties. Properties means you are including physical as well as chemical properties. Okay, so this is going to change the entire scenario of this entire part. Okay, now in this particular case, you can say it can be halogen, it can be any type of halogen, it can be fluorine, chlorine, bromine, iodine. Okay, it can be oxygen, or even it can be sulfur, it can be nitrogen. So depending upon these parts, like whatever species you are choosing, we have different type of functional groups. You already know certain names. You know the concept of alcohol, which is nothing but the presence of OH moiety. Okay, if I talk about the next part in this case, you know halo, which is basically fluoro, chloro, bromo, iodo. These are halo functional groups. In the same way, you have nitro, which is NO2. In the same way, you have amine, which is NH2. Okay, and there is one category which is known as carbonyl compounds. In case of carbonyl compounds, you can have CHO, which is known as aldehyde. You have COOH, which is known as carboxylic acid. Okay, you can have ketone, C double bond O is ketone. In the same way, you have C double bond O, which is known as ketone. Okay, I can say you have oxygen, which is known as ether. You can have halo acid, COCl or COX. If I talk about the next part, you have amide, which is C double bond O NH2. So there are different type of functional groups. I am just giving you the basic idea. We are going to discuss about the nomenclature of each and every type of functional group definitely according to their preference, but this is the basic idea. So these are the basic relation related to the concept of functional groups. I hope this entire portion is clear. Just have a look at it, note down this entire portion. Okay, now the next part is a very interesting. Next part is basically related to the classification. Classification of organic compounds. This is the most interesting portion because nomenclature always starts if you know the basic idea, like what is the actual representation of organic compound and how it looks like. So in this particular case, you can say the first part is basically The first part is basically known as open chain organic compounds, okay, or known as acyclic organic compounds. Second portion in that case will be closed chain, or also known as cyclic organic compounds, okay. Name itself says that if we have the open structure, then definitely this will be the acyclic compounds, or also known as open chain organic compounds. If this two ends are going to meet themselves and they are going to form a cyclic ring, then definitely we are talking about the closed chain or cyclic compounds. Now in this particular case of open chain, you have three different categories. First one is known as alkane, next one is known as alkene, and last one is known as alkyne. Means carbon single bond carbon, carbon double bond carbon, carbon triple bond carbon. If I talk about their formula, you already know this is CnH2n plus 2, CnH2n plus 2. This will be CnH2n and this will be CnH2n minus 2. Okay, so that is the basic idea about the open chain type structure. In case of a closed chain, you have the classification. Functional groups are always present in every case, so don't worry. Next part is known as alicyclic organic compounds, and next one is known as aromatic organic compounds. Okay, so this is again classification. You can say in this particular case we have simple carbon carbon cyclic structure, and in this case there will be no alternate double bond system. There is no system like alternate double bond system, because that is the property of aromatic compound. In this case there is alternate double bond system. Okay, so there is one specific part how you can differentiate aromatic as well as alicyclic compounds. So there is one part which is known as the Huckel's rule. So if Huckel's rule is going to apply, that compound is your aromatic compound. That part we are going to discuss in the aromaticity, but just remember this is the basic idea. So if we have a system which is alternate double bond system, just like benzene, you can see benzene has alternate double bond system. So definitely that will be the aromatic compound. A closed chain structure should be there, but it should be your alternate double bond system. Now in this case, this acyclic as well as aromatic part again divided into two portions. First one is homoatomic and next one is heteroatomic. Okay, homoatomic means if I talk about the homoatomic, only carbon and carbon bonds are present. Heteroatomic means carbon with other atom also. Carbon with other atom also. Mainly in this particular case, we have either oxygen or we have nitrogen. Sometimes it may be sulfur, okay, but most of the times it's oxygen as well as nitrogen. I hope this entire part is clear. This is the basic classification related to organic compounds. There is one more term which I want to mention here, and you should be familiar with that term. First one is saturated hydrocarbon. First one is saturated hydrocarbon. What is the meaning of this term? Saturated hydrocarbon means only carbon single bond carbon is present. Those hydrocarbons in which only carbon single bond carbon is present. And next one is unsaturated hydrocarbon. Next one is unsaturated hydrocarbon, in which carbon double bond carbon is present, carbon triple bond carbon is present. Those are actually known as your unsaturated hydrocarbons. Okay. So these were the prerequisites which were required to understand the basic idea of a nomenclature. Okay. If you know these things, the entire part is clear. Okay. Okay. Now let's start with the next portion, which is the concept of nomenclature. Okay, so nomenclature means the naming of organic compounds. It is basically the naming of organic compounds. Why we have this nomenclature? Because uh, we have different countries. In India, maybe we are using the name of methane by some other generic name, or maybe in case of US, the name is is a different one, I can say. In Russia also, they are using a different name for methane, a generic name. So this might increase the confusion between the scientists. If they are using the same compound with different names, it's going to create a chaos. So to decrease this I can say difference, or you can say the problem related to the confusion of their names, IUPAC, which is International Union of Pure and Applied Sciences, they actually gave certain rules to define the name of a particular organic compound according to some set of rules. So if I talk about the naming of organic compound, it actually occurs by the IUPAC rules. Whatever rules they have given, we have to follow these rules so that every organic compound is going to have a same type of name. Either we are present in India or in US or in any other country. If you are going anywhere, the compound, the name of the compound is going to remain same. So in that particular case, the rule of nomenclature is very easy. The rule of nomenclature is very easy, and you already know certain idea from your 10th class. What is the idea in this particular case? Always remember that just like our own name. So if I talk about my name, it's basically Arpit Bharadwaj. If like if somebody is going to use that name with respect, it may be like Arpit Bharadwaj sir, or Shri Arpit Bharadwaj, like that. So you know certain if I talk about the teacher, like the greatest teacher of all time, which is Sir Richard Feynman. So we generally use Sir in front of their name, Richard Feynman. So that is the basic idea. So if I talk about the name, in my name also, which is Arpit Bharadwaj, you can see the name. My name is actually Arpit, but my surname is Bharadwaj. It may be possible that there are different type of surname also. So one of my friend has a name which is Divipal Singh Chauhan. So you can see in this particular case, Divipal is his name, and there are two surnames. First one is Singh and next one is Chauhan. So you can see like there are different possibilities in case of our own nomenclature. So just like that, the organic compounds have the same type of nomenclature. The actual name in my case is actually Arpit. In my friend's case, it's actually Divipal. It may be possible that there are certain people that they have different type of names, like Joginder Pal Singh, or I can say, I'm just using some random names. Okay, so don't worry, don't try to correlate with anything. So or you can say Digvijay Singh Pariyar. So definitely in this case, you have a actual name, then you have surname, first surname, then you have second surname. So just like that, nomenclature actually works like this thing only. Okay, so you have first part which is known as word root. Okay, first part is your word root, the actual name. The actual name is actually word root, and word root actually represent total number of carbon atoms in parent chain. This part we are going to discuss what is parent chain, but the basic idea of a word root is basically total number of carbon atoms in parent chain. Then you are going to use suffix. This one is known as primary suffix. This one is known as primary suffix, like Devipal Singh Chauhan. So Singh is the primary suffix. So that corresponds to, in this particular case, unsaturation. It only talks about unsaturation. If double or triple bond is present, then you need to use the primary suffix, which is "-ine" as well as "-ine". Next part is basically your secondary suffix. Next part is your secondary suffix. This is the most important portion. This actually talks about the functional group. This actually talks about the functional group. Okay. So this is the first part. So word root, then we have a primary suffix, then we have secondary suffix. Just like that, we have primary prefix. Prefix means Shri, Sir, Shri Shri 1008, just like that. So this starting portion of a particular name, if you are using the name of an of a particular person with proper respect, then generally we use a sir, or we generally use a Shri in Hindi also. So that is the basic idea of the prefix part. Okay. So first part is a primary prefix. First part is primary prefix, which only talks about the presence of or differentiate between cyclic and acyclic. So this part is generally used for cyclic compounds. Okay, this part generally used for the cyclic compounds. Then you have certain part which is known as secondary prefix. Then you have secondary prefix. This generally talks about the I can say side substituents, side substituents, or it talks about the other functional groups, or I can say functional groups other than, or I can say functional groups other than these parts, secondary suffix functional groups, other than secondary suffix functional groups. Okay. So always remember, these secondary suffix are the main functional groups. These are main functional groups which are going to define the properties of that particular organic compounds. But it may be possible different functional groups are present. So one will be the actual functional group, and rest of the functional groups are basically your sides suffix, I can prefix, or I can say secondary prefixes. Okay, so this is the entire portion you have to understand, that we have secondary prefix, then primary prefix, then word root, then primary suffix, and then secondary suffix, if you have an enormous question containing each and every part. Okay, just have a look at it. Okay, now let's try to decode first part, which is related to the primary prefix, word root, as well as primary suffix. It means I'm including, first part includes simple hydrocarbons, which is basically alkane, alkene, and alkynes, as well as cycloalkanes, spiro, as well as bicyclo compounds. Okay, first portion will be this entire part. First of all, we are going to determine the nomenclature of simple hydrocarbons. Okay, so that will be the nomenclature of simple hydrocarbons. Okay, okay, so just note down this entire portion. Okay, now let's start with the nomenclature part. Let's start with the nomenclature part. And in this case, we are using the nomenclature of simple hydrocarbons. Okay, simple hydrocarbons. Okay, so in this case, there are certain set of rules. There are certain set of rules which you have to understand. First one is your parent chain. You have to decide what is going to be the parent chain. Parent chain means the chain containing maximum number of carbon atoms. Basically, the chain which contains maximum number of carbon atoms. So first task is to select the parent chain. Okay, so first task is parent chain selection. First task will be parent chain selection. So chain containing maximum number of carbon atoms is going to be your parent chain. After deciding the parent chain, if you are confused that more than one parent chain are present, more than one chain with same carbon atoms, if any chance is there that you have more than one chain which are having same number of carbon atoms, with same carbon atoms, then select the chain with maximum branching, okay. So these two rules are very important whenever you are selecting the parent chain. For example, I can start with carbon, 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 and carbon, carbon, and then carbon and carbon, okay, or you can say carbon only. Okay, so in this case, what you can do, you can say 1 2 3 4 5 6, 6 carbon atoms are there. 1 2 3 4 5 6, 6 carbon atoms are there. 1 2 3 4 5, okay, or 1 2 3 4 5, or 1 2 3 4, different chains are present. Parent chain will be the chain which contains maximum number of carbon, so that will be your parent chain. Now next part, let's say we have a carbon, 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 1 2 3 4 5, 1 2 3, or I can say carbon, okay, like this, like this. Let's say this is the possibility. So I can say 1 2 3 4 5, one part is there. 1 2 3, 1 2 3 4 5, 1 2 3 4 5, and next part is, let's say, 1 2 3 4 5. So different chains are present, carbon 5 atoms. Now in this particular case, if you are selecting this part, if you are selecting this part, how many side atoms are there? One branching is there, two branching are there. So this chain actually includes two branching only. Now let's say if I am using this chain 1 2 3 4 5, let's say. So in this case, let's say I am using this carbon chain, then again you can see 1 and 2 branching are there. Is there any other possibility? Okay, one more possibility, 1 2 3 4 5. If I am using this part, if I am using this chain, let's say if I am using this chain, again it has 5 atoms, but the problem is you can see only one branching. So neglect those type of main chains which contain only one side atom, one branching, or less number of branching. Always use that part which contains maximum number of branching. So either you can select this part because it contains one side atom here, one side atom here, or you can select this entire part, one side atom here and one side atom here. Okay, I hope this part is clear. Just have a look at it. Okay, let's talk about this example. So in this particular case, we have 1, 2, 3, 4, 5, 6, 7. So one carbon chain containing 7 carbon atoms. Now in this chain, you can see one branching is there and one branching is there. Branching means the side atoms which are originating from the parent chain carbon atoms. So only one side is there, one side is there. So in this case, you can see in this particular case, we have two branches and 7 carbon atoms. Two branches and 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. Definitely. Now there might be a chance, that we have another possibility, that I can say 1, 2, 3, 4, 5, 6, 7. One more part is there, which is like this, 1, 2, 3, 4, 5, 6, 7. Again 7 carbon atoms, but in this case you can see one branch is there, one branch is there, and one branch is there. So in this case, again we have 7 carbon atoms, but now in this case we have 3 branches. So I'm going to give the preference to that particular parent chain which contains maximum number of branches. So that will be the preference. That is not going to be the preference. Okay. I hope this part is clear. Okay. Now moving to the next part. If we have selected the parent chain containing maximum branching, then it's time for the numbering part. Third part is numbering. Numbering of parent chain. So always remember, whenever we talk about the numbering of the parent chain, in that case always use lowest locant rule. Always use lowest locant rule. What is this lowest locant rule? The meaning of this entire part is very easy. Always start the numbering from the side of nearest branching. Okay. So always use the side which has the nearest branching, or it may be possible which has lowest sum of all branching. Okay. So one part is lowest locant rule, Next part is lowest sum rule. Next part is lowest sum rule. Or it may be possible if numbering is same, then use the alphabetical order. I know it's a lot to digest. These rules are a lot to digest, but with the help of examples, you will get to know what I'm trying to say in this entire case. Okay. So three things you have to remember: lowest locant rule. If only one side substituent is present, you can start the numbering from that side which has lowest number. Or if you have multiple branching, then you can use the lowest sum of all the numbers. And if entire part is same, then you can use the alphabetical order. Okay. This is the entire part. But for alphabetical order, for lowest sum, for the lowest locant rule, you should know how to write down the side substituent. So in case of alkanes, just note down this important point. So alkane is CnH2n plus 2. If I am removing one hydrogen, it became CnH2n plus 1 only. And that means it becomes alkyl. Alkyl. Methane becomes methyl. Ethane becomes ethyl. Propane becomes propyl. Just like that. Okay. So methane, it means methyl. This is a CH4. This is CH3. Ethane, which is C2H6. C2H5 is going to be ethyl. Propane becomes a propyl, butane becomes a butyl. Just like that, this is the basic idea about the side substituent. I am only using side substituent which is simple hydrocarbon only in this lecture. Okay. Now, for example, this is the situation. This is the situation. So I can start the numbering from 1, 2, 3, 4, 5 and 6, or I can start the numbering from 1, 2, 3, 4, 5 and 6. If I am using this numbering, first branching appears at the position 2 nearest. From this side, first branching appears on the position of a 3. It is far. So I can prefer this side, not this one. Okay. I hope this part is clear. In this particular case, I can use any of the chain. I can use any of the chain. So in one case, it may be 1, 2, 3, 4 and 5. So first substituent is present on the second position. If I am starting with this particular part, 1, 2, 3, again same problem. The lowest locant rule is not going to occur in this particular case. So that is the actual numbering. Now in this case, we are using three branches. So 1, 2 and 3. If I am using this nomenclature, 1, 2, 3, 4, 5, 6 and 7. So you can see the side substituent are present on third position, then fifth position and then sixth position. It may also be possible that I can start from the reverse side. So that will be 1, 2, 3, then 4, then 5, then 6 and then 7. It may be possible if I am using the reverse side. Okay. So in this case, you can see the position will be 2 and then 3 and then 5. So that will be 2, 3 and 5. So in this particular case, you have to use the lowest locant rule. So you can prefer that side, not this numbering. Okay. I hope this part is clear. I hope this part is clear. Okay. Just have a look at the rule and let's try to decode certain questions. Okay. Let's try to decode certain questions. Okay, let's try to decode certain questions. First of all, select the parent chain, then try to use the numbering and apply all the rules which are lowest locant rule. Okay, so in this case I can use 1, 2, 3, 4, 5 here. If I am using this entire part, only one branching will appear, or I can use 1, 2, 3, 4, 5. So one branching here, one branching here. Definitely I am going to use this entire chain as the parent chain, this chain as the parent chain. Now what about the numbering? In that case, you can start with the lowest locant rule. So 1, 2, 3, 4, 5. So that the locants will be present at the position of 2 as well as 3. Okay, clear? I hope this part is clear. Now in this particular case, I can say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so I can use this chain as the parent chain, this chain as the parent chain. Numbering will start from 1, 2, 3. First substituent will appear and at 3 position, and 1, 2. So that will be the actual position 1, 2, 3, 4, 5 and 6. So locants are present at 2 as well as 4 position. Okay, I hope this part is clear. Next part, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I can use this chain as the parent chain. Numbering will start from 1, 2, 3. 1, 2, 3. Wherever you can start from wherever, because both the positions are same. So 1, 2, 3, 4, 5 and 6. Locants are present at the position of 3 as well as 4. Okay, it's not going to matter. In this case, I can use the chain like this, longest chain. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, numbering you can start from anywhere, both the positions are same. So 1, 2, 3, 4, 5, 6 and 7. So substituents are present at second as well as sixth position. So 2 comma 6. I hope this entire part is clear. I hope this entire part is clear. I hope this entire part is clear. Now, what about the actual name of these compounds? How to write down the names? So names are very easy. You just have to remember the actual nomenclature I gave you. Secondary prefix, then primary prefix, then word root, then secondary suffix, primary suffix, then secondary suffix. Okay, just look at these structures. There is no presence of any functional group. It means the secondary suffix is out of the equation. These compounds are open chain compounds, means primary prefix is out of the equation. We cannot use the cyclo because these are acyclic compounds. Okay, so in this particular case we have total 5 atoms. 5 atoms means word root will be pent. Okay, so if I talk about the word root, I can again explain this entire part. Okay, so this is the word root. Then we have primary suffix, then we have secondary suffix, then we have prefix, then we have secondary prefix. This talks about the side substituent as well as other functional groups which are present other than the main functional group. This one only talks about the presence of a cyclic structure. If there is acyclic structure, no need to include this entire part. Word root means total number of carbon atoms in the parent chain. This talks about the degree of saturation and unsaturation. If double bond, it means this is ene. If triple bond, it is ine. What about single bond? Carbon, single bond carbon. It will be ane. It will be ane. Okay. So in the nomenclature itself, I can say that if I talk about the word root, it's very easy. One carbon atom means it is meth. Two carbon atoms, eth. Three, prop. 4 bute, 5 pent, 6 hex, 7 hept, 8 oct. Okay. 9, it is a non. 10. So basically I'm using certain word roots in every case. So meth, eth, prop, bute, pent, hex, hept, oct, and dec. Okay. If I talk about the 11, this one will be undec. 12 will be dodec, and same way tridec, tetradec, pentadec, hexadec, heptadec, octadec, nonadec, and icos. Okay, so this is the actual part. Although these are very these are very far. Generally, we are going to deal with this portion only, oct up to oct only, or max to max non as well as dec. But you can remember this one is going to be undec, dodec, tridec, tetradec, pentadec, hexadec, heptadec, octadec, nonadec, and last part is icos. Okay, so always remember, you can write down by your own. So in the same way, if I talk about this entire part, we have 5 carbons. So pent, only single bond is present, means ane. There is no functional group, nothing to worry about. Now, what about the nomenclature of prefixes? So in this case, you can see on second position, we have this group, which is generally this entire part corresponds to CH3. And if you expand this, this one will be CH2, CH3. Okay, CH2, CH3 is ethyl. So this is basically ethyl, and this one is basically methyl. If it is like that, then you have to follow the alphabetical order while writing the name. So in this case, it will become on third position. On third position, it is ethyl. On second position, it is methyl. Then pent plus ane. So the actual name becomes pentane. Okay, I hope this entire part is clear. Now one thing which I want to mention here, just note down that important point. Whenever you are writing number and word, one hyphen should be there. When you are writing number and number, one comma will be there. And when you are writing word with word, there should be no space in between. Okay, these three things you have to remember whenever you are dealing with the nomenclature part. Okay, I hope this part is clear. Okay, one more thing which I want to mention, just note down. In case of simple side substituent, in case of simple side substituent, if more than one side substituent is present, if more than one time, you can use if more than one time a side substituent is present. It may be possible that methyl is present 2 times, then you can use di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, just like that. Okay, so you can use this entire part. Just note down this important portion. Now for this entire part, you can see the main chain will be 6 carbon atoms. There is no double bond, so the name will be hexane. It's done. But what about these side substances on second position and fourth position? You can see both groups are methyl group. So in this particular case, I told you, you have to mention each and every position. So on second position as well as fourth position. So number and number separated by comma. Then number and word is basically by hyphen. In this case, two methyls are there. So dimethyl. So it's going to be 2, 4 dimethyl hexane. So that is the actual name of this organic compound. Okay. In the same way, if I talk about this entire part, again you can see 1, 2, 3, 4, 5, 6, 7. 7 means heptane. 7 means you have heptane. Okay. But the thing is, on second and sixth position, you have same group, which is methyl. So what you can do? You can say 2, 6 dimethyl heptane. That will be the name of this organic compound. Okay. I hope this entire portion is clear to everyone. We have discussed some basic idea related to the nomenclature part. Okay. So just note down these important points. Rest of the part we are going to discuss in the next portion. Okay. So we are going to start with the nomenclature of first part, which is simple hydrocarbon. Then we are going to understand the nomenclature of the compounds, which are your unsaturated hydrocarbons, which are double bond and triple bond hydrocarbons. Then bicyclo spiro compounds. Then we are going to move to the next part, which is nomenclature of functional groups. So basically we have total 3 lectures of nomenclature. This is the first part, some basic portions related to the nomenclature. Try to write down each and everything because these are important portions. Rest part we are going to discuss in the next class. Okay, rest part we are going to discuss in the next class. I hope everyone enjoyed this session, learned something new from this session. If you have any doubt, any doubt, okay, don't worry, we are going to discuss more elaborately in the next upcoming sessions, 2 sessions, about the nomenclature of organic compounds. But if you guys have any doubt, just let me know in the comment box. Okay, so that's all from my side. Thank you so much. नहीं नहीं